Oh, that's good.
So maybe let's. Where is the screen? Top right hand of the screen.
Should we open the PDF in PDF viewer?
Could be.
I don't think this is fine.
First thing is coming. Not sure if to help or somewhere else.
Full screen.
Right button. This button. And then you still have to go to
Yeah, full screen.
Thank you.
the full screen. You have to do it in this sequence because if you do it the other way around, the clicker doesn't work.
I see.
Thank you.
And then in 4 months,
The clicker doesn't work right.
Yeah, so we need to do this.
Now it does.
Yeah,
Okay.
thank you. Okay, let's get started.
Should we?
Yeah, it's already time. 2 minutes past, I think. So you want me to go through the
Yes, please.
intro? Okay. Okay. Hello, everyone. Welcome to the meeting of the 6 Law Working Group. Please make sure that you are in the right room. My name is Carlos Gomez. This is Shweta Pandari, and our responsible AD is Suresh Krishnam. So we have a minute taker. Dominic kindly volunteered to taking minutes, so thank you very much, Dominic. And Pascal also, thank you very much. And by the way, we understand that the minute taking will happen over the Etherpad, so feel free to join the Etherpad to contribute to the collaborative process of taking minutes. Then we would also need the JavaScribe. Is there anyone who would like to volunteer as JavaScribe? Thank you very much, Georgios. So then on the slide, you can also find pointers to important resources such as the online agenda, the Java Room, the Meet Echo, and the Etherpad. Oops. This is the usual Notewell. It contains a number of pointers to IETF policies on important topics, so please make sure that you have read it. And this is the agenda proposed for today. So the first slot is the usual chair's introduction and report of the working group document status. After that, the second slot is dedicated to the fragmentation-related drafts, which will be presented by Pascal. Here we would like to propose a change compared with the agenda that was originally announced. We would like to actually transfer 5 minutes from the chair's introduction to the fragmentation slot. So we would have 10 minutes for each part, the introduction and fragmentation. Is there any objection against this? Okay, thank you. So then the next presentation will be the update of IPv6 mesh over BLE links after the Shepherd review. The next one will be the presentation of the update of the 6th law applicability and use cases document presented by Youngjun Hong. And after that, we'll have the presentation of the update of IPv6 over PLC draft by Remy. After that, we have the first presentation of a new draft, which is entitled IPv6 over Controller Area Network. This will be a remote presentation given by Alexander. And after that, we have yet another presentation of a first version of a draft, which is entitled Comparison of 6LoW and CHIC, which will be presented by Laurent. Finally, we'll have a presentation of the draft entitled Asymmetric IPv6 for IoT Networks. So this is an update after the previous presentation that was held in Montreal. By the way, you can notice that the two last slots in the agenda correspond to considering alternative techniques for header compression, for example. So we expect to have a nice discussion on this topic. Is there any comment on the agenda? Okay, thank you. So now let's go through the report of the working group documents status. And this will be presented in decreasing order in terms of maturity as usual. So first of all, we have the packet delivery deadline time document, which is in the RFC editor queue. That's because it is awaiting the publication of the 6-stage architecture document, which will be normative in this document. And the next one is IPv6 over NFC, which is in AD follow-up. I don't know if Suresh, you want to. Yeah, so as you may recall, this draft was evaluated by the ISG. There were a few discussed positions, and the authors updated the draft and actually replied to the ISG members who had made comments and issued discussed ballots. However, the status of the document has not changed since then. In fact, we have not received feedback from the ISG since Montreal. So perhaps, Suresh, is there any hint on when we might get feedback?
Yeah, I'll take a shot at the first 6 ones, right? So packet the deadline time, we found mathematical error in the deadline time calculation. It's been approved. It's in the RFC editor queue. So there's something I need to update the IESG on. There's some new text. Thanks a lot for Charlie for working on it. So we need to. I'll talk to you about it a little bit. So the NFC, the biggest issue was the tone of the document that caused a lot of the discussions. It looked a lot like a marketing document for the technology. So it's kind of been rewritten, and I'm talking to the discussing ADs to get this cleared, but I don't have a clear indication of the stuff that's needed to change as well, like in the specific text changes, but it's more about the tone of the document in there. Okay. The APND, I finished my AD eval. I haven't written up. I wanted to send it before this week. That's actually the first thing on my queue, right? Once I send it to, hopefully Pascal can turn around pretty quickly on the APND draft to submit it. There's some changes that are required. APND. Oh, no, not yet. I haven't sent it. That's what I'm saying. So what happened with this draft is we were in a IEEE coordination meeting, and they said they wanted to look at it. So I was waiting on the IEEE folks to get back, and they got back and said they didn't care about it, frankly, right? So that kind of took a 3-month detour through the coordination process. And so that's done. So once that's out of my way, I'll get the other documents done, which are pretty simple compared to APND. Yeah, that's from my side. So that covers the first 6 documents.
Thank you. So then there's the next 3 documents which have been recently entered the AD evaluation state. So the first 2 is 6LoWPAN fragment forwarding, which fragment forwarding and fragment recovery. So the first 2 are the ones related with fragmentation. The first one, 6LoWPAN fragment forwarding, has been already evaluated by the Internet Area Directorate. Actually, Dave Taylor provided a review, has engaged in discussion with the authors. So thank you very much, Dave, for this. Then the next one is the fragment recovery draft, which is expected to be reviewed by the Internet Area Directorate by end of this month. And the backbone router document was, since after Montreal, was reviewed by 6 man, and after that the authors updated the document, and well, recently it entered also the AD evaluation state. So after that we have also the IPv6 mesh over PLE links document. Here the Shepherd has done the review of the document. The authors have updated the draft, and provided that this update satisfies the comments of the Shepherd, then the next step would be getting the Shepherd write-up. Then we also have the 6 law applicability and use cases document. As you may recall, there was a working group last call which ended without feedback for this document a few months ago. However, recently there has been some feedback on the mailing list. For example, Pascal provided a review of the document, so thank you very much for that. And also after the deadline, the internet draft submission deadline, there was also some further feedback on the mailing list by Remy. So today there will be a presentation of the latest revision of this document. And the last working group document, which is the IPv6 over PLC draft, has also been updated recently. So it will also be presented today. Any comments or questions?
Yeah, Suresh Krishnan. So I'm glad there's like some feedback on the use case document, because I was really worried that it's just going to die, because like it didn't look like anybody was interested in it. So I'm glad it's like making some progress. I still don't know if there's like enough critical mass behind it to take it through, but I'm at least glad that something is happening in that space.
That's good.
Yeah, so the next presentation is fragmentation, given by Pascal.
Okay, so I was not sure initially that I would need the slot, and then things happened. So that's why I asked the chairs, and I thank you so much to make a little bit of room for that discussion. So we have 2 fragmentation documents. One is the minimal fragment, which is a very generic specification, does not give implementation details, but global implementation recommendation or constraints or overview. And the other one is fragment recovery. And the minimal fragment also discusses a particular implementation or describes it or points to it. That particular implementation is the LWIG 6LoWPAN virtual reassembly buffer thing. So then there is a full section, one of the biggest sections of documents actually to describe that. So both passed for group last call, as Carlos mentioned. And so I'm just giving you the update of their life after death. So the thing that really happened is that thank you, Dave, thanks so much. We had a number of front trips between me and Dave, actually. So I kind of took over because Thomas was not available. He was the initial editor, and that actually is also part of that discussion that we had. Is maybe Thomas and I were not 100% in sync about the content of this document. So that's why it's worth coming back to the working group, because initially the document did not really have an introduction to explain what it was about. So that was the first reason why we had this discrepancy. And second, most of the text was, here is how VRB works from up there. And what it did not do enough, to my taste at least, was to say, hey, here is what any fragmentation forwarding should be doing. And that includes swapping the datagram tag and our reasons for that, and that should be explained somewhere. And also some things we discovered when we started implementing those drafts, and in particular, we can thank Raoul for all the, so I don't know if Raoul is with us. Is not, but he published a number of results of implementation and measurements, and that's really clarified the pros and cons of using this technology and how it can be misused to the point that forwarding fragment is actually worse than recomposing at every hop. So the feeling I had, on trying to answer Dave's point, was that this should be described in more detail. There's a need to tell the world that, okay, the IETF has looked at what it is to forward fragment. There is one particular way which is described in details down to the implementation, which is VRB. That's great. VRB enables to do it with RFC 144944, the way it stands. Now, there are things that VRB and any other fragmentation, including the reliable fragment, needs to do anyway. There needs to be an overview to explain those things. And if you do it wrong, and if you fall into one of those pitfalls, then you get very bad results. Avoid them. So I added quite a bit of text in the document, and we had a number of round trips to just provide that, which makes it so that now the document has uppercase text. As it stands, I don't know if it's published or in the GitHub repo, but it has uppercase text, which makes it so that there is a next comment by Dave, which is, where is the BCP14 text to say what those uppercase mean? And coming back to the fact that if you have those uppercase text, like you must swap fragments at each hop, we are back to the question whether it's normative, it's a standard track or informational. So there are really those two aspects, right? There is more text than before, which is generic to any fragmentation. There is uppercase in there. There is also all the text about the pitfalls in which you may fall, the things you have to do and things you have to avoid. And because of that, we have uppercase. And even if it's a very generic, it cannot be implemented as is because it's high level. It's more like for a family of solution. It still gives you mandatory things to do. So question to the group, do we want informational standard track? Question to Suraj as well.
Yes, I think it's normative, personally speaking.
Okay, so I will add the BCP14 text and republish, I guess. And thank you so much, Dave. You were very responsive and all. That was really good. That's it for this one. So the fragment recovery also lives its own life. So later today, Laurent will present us the fragment recovery that the SHIC protocol provides that was designed at the LP1 working group, which is a very thought out, very well designed fragmentation mechanism. And one could say that it kind of competes with this one, which I don't know in which details you're going to go, Laurent. But the bottom line is one is very optimized for one hop. And I think it does a better job than this one if there is just one hop. But the real problem that this draft addresses is not when it's one hop, because we have the layer 2 acknowledgements in most of the 6 law cases. So it's really the multi-hop problem that this draft addresses, and that's how they differ.
Yes, Laurent Toutain, I will not talk about fragmentation because I agree with you.
Oh, you're the best. I would like a working group of people like you. No, it's a bad joke. Okay, so the only comments we had was implementation comments by Martin. So thank you, Martin, if you're hearing us today. I don't know if you're. So that the discussion was, it's interesting. I need to mention it because the question was, okay, what if I'm forwarding this fragment and I hit the hop limit of the packet? Obviously, I cannot forward it more, and you would figure, oh, is it different if the packet is recomposed at every hop or if it's fragmented? And at the end of the day, that brings up the question of I have this fragmented 6LoWPAN packet and there is an error with it. And the error may come because it was fragmented or because it was compressed by 6LoW, maybe in the wrong fashion or something, or in a fashion that the next hop does not understand, versus it's a problem with IPv6 itself, like MTU, like in this case, up limit or anything else. How do you report that to the source? And it's even worse than that. Who is the source? Because if you're recomposing 6LoWPAN at every hop, and the prime has to do with the 6-lopan compression or fragmentation, then maybe the source of the prime is not, the guy who passed the packet at layer 3 at the other end of the mesh. It's really the hop before you. So how do we process ICMP errors in general, and to whom we send the error back, and what goes into the packet? For instance, if the prime is really due to the compression or the fragmentation, and you do what Martin did, which is recompose the packet and then build the ICMP error with the recomposed packet, you lose all track of what was in the compressed form. And if the error was there, then you lose the information about the error. So seems to me that we kind of overlooked all this ICMP error game, mostly if you have multi-hops, and that could deserve some attention by this group in the future. So I mean, we discussed what she could do. She does what she can. I mean, the problem is it's actually unspecified. So what she did was proper, but mostly for hop limit, because really it's a problem with the IPv6 packet, so that's when it's kind of clear. So if she recomposes the packet, fine. I argued actually that she did not need to recompose the packet because the hop limit is in the first fragment. So she could have sent the error back on the first fragment with the first fragment in, and then drop the next fragments. And the cool thing with that is the error flies back to the source maybe before all the fragments are sent, so the source doesn't waste bandwidth sending all the other fragments. So what she did was proper. It was actually not optimized, but since there is no spec, right? And it's not specific to this fragment forwarding draft. So I said, I don't see why we should put the text in there, but there should be work to actually address this. And that's pretty much my discussions, and the drafts are in the caring hands of Suraj.
Okay, I'm going to present the current status and the last update of the draft entitled IPv6 Mesh over Bluetooth Low Energy using IPSP. So first of all, let's take a look at the status of the document. The previous version, which was 0.5, passed working group last call, and then the shepherd, Rahul, kindly provided a review of 0.5, and then we produced version 0.6, which is intended to address the shepherd's comments. So now let's take a look at the updates in this last revision. First is, after a comment by Rahul, we found a few instances where we were still using ARO, whereas we should have been using EARO, which is the term defined in RFC 8505. This was actually a couple of instances in the header compression section. Then Rahul also commented on the use of 6CO. He explained that perhaps the 6CO is not needed to be supported if a single prefix is going to be used in the network. So we thought this was a good idea, and we decided to relax use of 6CO, the requirement on using the 6CO from a must to may. Then there was a third comment, which was mostly editorial, intended to express a bit better some sentence. Hopefully now it's more readable. And finally, Rahul had also a request to provide some diagram illustrating the node joining procedure. So we did that. We added Appendix B, which now contains the diagram that was requested and also a text description of what's happening in the diagram. So this is a quite typical message exchange. Here in this diagram, the new node is the 6LN in the figure. So basically, the 6LN starts sending a router solicitation message. So if there's some node, a 6LR in this case, in range of the new node, then it will reply with a router advertisement. So the new node will be able to configure its global IPv6 address because it has now learned the prefix in use, and it will register the IPv6 global address with its router. So then there will be the multi-hop duplicate address detection procedure, and finally the 6LN will receive the result of this procedure. So this is all regarding the updates in this new version. Is there any question, any comment? Okay, so next is the 6 law applicability and use cases.
Hi, this is Yonggun Hong. I present the 6th row, the use case and applicability document. Could you adjust
Try now.
Yeah. So after the last meeting, there are 2 updates, the 7th version and the 8th version. So the 7th version was reflected by the decision of the authors, and the 8th version was updated by reflect the Pascal comment. So I thank you to Pascal for your sincere review and comment. So in this latest draft, we have the 6 row link layer technology, G-Wave, BLE, DECT-ULB, MSTP, NFC, PLC. So the last, the IEEE 82.50.echo, our authors decide not to include the 6 row link layer technology, I said in the letter. And this the comparison table across 6 row link layer technology. So G-Wave, BLE, DECT-ULB, MSTP, NFC, PLC. So that's the reason we released the DSCH. So in the 6 row deployment scenario, so originally we have 4 practical 6 row deployment scenario: Ju Python Mesh, Python, G3 PLC, NetRest. So among them, we remove Ju Python Mesh and Python because that technology is based on IEEE 82.15.4. So currently, 2 deployment scenarios such as G3 PLC, NetRest are remained. So we have the guidelines for adopting IPv6 stack, for example, addressing model, MTU constellation, mesh or L3 routing, address assignment, head comprehension, security and encryption, additional processing, etc. So in the current, the latest draft, we have the use case of the each 6 row link layer technology. For example, G-Wave, it can be used to smart home. For example, the BLE, it can be used to smartphone-based interaction. And for example, NFC can be used to alternative the secure transfer. And for example, PLC can be used to smart grid. Okay, so this is the summarize the comment after the last meeting and the email discussion between authors. So I remember that in the last meeting, maybe the Suresh gave the comment that this draft must be the scope narrowed down and we must focus on something because it is a little too broad. So I agree and I thanks to your comment. And we also have some agreement there. So to do this, we decide, okay, we must adjust the scope. So narrow down and focus. So previous version, the draft is 29 pages. So currently is 25 pages, 4 pages are reduced. And we try to make consistency between each section. So email discussion between authors. So we determine 6 row technology. So there are some items regarding this. LPWAN related technology are out of scope. So in the previous version, LTMTC is included, but we removed, and we try to focus on technology that have been handled after IRU 2015.4. So that's the reason we delete some related parts of the IRU 2015.4. And other technology which are not related to RFC or working group document are out of, for example, I remember that Pascal said that we have the WLAN AH draft in this 6-row working group, but it was too old. After 2 years, there are no active activity. So that's the reason we don't handle the draft in this document. So I detail explain the reaction from the comment from Pascal. Okay, this is the decision between authors. So I said that we remove related parts with the edit 2015.4 and edit 2015.4 echo. So the section 3.7, 4.1, 4.2, and appendix 8.6 in previous draft are removed. So update table 2. So in the previous version, we used the specified expression, but in this version, we remove specified expression, and we decide the 6-row linked layer technology, and we try to reduce the content and etc. Okay, this is the replies to the comment from Pascal. So Pascal suggests that it is better to reverse the standards and include a reference. So we do that. And Pascal says that the previous G3 PLC contents is a little out of the data. So we check that. So I found that, yes, it is a little too old. So we try to catch the current status of G3 PLC document. And Pascal gives some text for the address assignment. It is a little too not the proper. So thanks to Pascal again. So I reflect the text of the address assignment like this. Okay, this is the next step. So I'm asking of the floor for regarding to the scope of this draft, specifically the 6-row linked layer technology. To make the scope narrow down, we delete IEEE 2015.4 and IEEE 2015.4 echo, and also we delete the 6-row deployment scenario, for example, to Python Mesh and Python. So that's the result. We have only 2 6-row deployment scenario that is based on PLC. So after the submission, let me give some document. So the first one is related to this. So he suggests some solution how to handle the 6-row deployment scenario. And let me also suggest that in the section 5 for the bullet or mesh or S3 routing, it would be better to have the example for mesh routing, ROAD NGOR G3 PLC. So in the next revision, I will reflect this comment. Yeah, that's all. Thank you. So I'm asking to and want to hear your opinion too regarding of the scope of this draft. Is it the best way to delete many parts which is related to IEEE 2015.4 and echo and 6 WNAH, also to Python Mesh and Python is the best way. So I want to, it is appreciated to hear your opinion.
I'm just not too clear what the result of if you declare them out of scope, like I think Jupyter Mesh is kind of dead now, so it's kind of out of scope because it's not there, right? On the other hand, Wyson is highly deployed and lively, and I expect we'll have a Wyson 2, etc. So I guess it's interesting for the reader, at least to know that it exists, even if you don't go into details of what's being done there, because I guess the reason why it's out of scope, it's another domain, another entity that specifies it, and you can't really, apart from saying it's there and it does high-level things, you can't go into the details of what it does because it's kind of proprietary, or, well, it's their alliance, right? So I would say you still need to say it exists, and you still need to say it does use this technology, because you're there to say this technology is deployed. So it's important that it's mentioned.
Yeah.
15.4e, the reason why you're not expected to talk too much about it is because now it does not exist anymore. It is wrapped up into 15.4. So when you say 15.4, you actually include TSCH, because that's part of the main spec since 2015. So it's not worth mentioning it for a reader of today. And because your reference is to 15.4 without a date, that includes TSCH for anything published today. So you don't need to mention 4e. Obviously, the LOPAN in 6LOPAN is 15.4. So it's hard to say 15.4 is out of scope. That seems a bit harsh. So I'm not clear what you mean by saying 15.4 is out of scope. I think it belongs, right? 15.4 is the one core technology for 6LOPAN. That 6LO extended to other. So I'm not clear what you mean by 15.4 is out of scope.
Can I?
Yes, please.
So Rashkrishnan, I think what they're saying is, like, they don't want to describe the link layer technologies in the draft, right? Like, I think like just a reference should be okay. I don't think they want to, they want to talk more about the use cases of it rather than the link layer technology. I think that's what I understood from
but the next point says that because 15.4 is out of scope, Wyson is also out of scope. So which makes it.
I think everything is out of scope for a use case document personally. Like, I like Pascal's thing. I would just say, hey, like, this is probably applicable to these technologies and be done with it, right? Without like spending too much time on the technology itself. Okay. Does that make sense?
Okay. But any use cases pertaining to these technologies are still in scope.
Absolutely.
Right? Yeah.
Like, I think it specifically says the link layer technology description is out of scope, right? That's pretty much it.
Okay, thank you.
One question. So we have this new work on the Canvas, which is going to be presented a little later. Do you see any new use cases coming in because of 6LO over CAN?
Actually, we must carefully check the canvas. So if we mature and it has some relation to 6LO, then we have a chance to capture the canvas.
Okay.
But I don't, right now, I cannot answer your question.
Sure. So in that case, we just keep the document alive for some more time, because we might get some more use cases.
The more important thing is the activity must be live in this area.
So you're not asking for work groups class called at.
Yes.
Okay.
Okay, thank you.
So I'm going to talk about the IPv6 over PLC networks. So some recall of the background. The objective of this draft is to define an IPv6 adaptation layer for constrained PLCs. It is based on some already done IETF standards and some extensions to these standards. And the scope of this draft is the constrained PLCs, which includes the ITUT G.9903, IEEE 1901.1 and 1901.2. And for the status of the draft, it was started in 2017, and it is adopted in this year in February. And for the version 00, we just uploaded it as a working group document, and with just a simple change of the title and some editorial modifications based on Carsten's comments. And in the version 01, we have done some modifications in the structure and update the neighbor discover section. And then I will talk about some modifications. For now, we have removed the section about the extension as the 6-low adaptation layer. It is we just remove it for now, and because it is the extension about the command frame header, it is currently unique in the ITUT G.9903 PLC, and in the other two PLCs in the draft, we just have not use case for this command frame header yet. And there is some inconsistency, in fact, in the order of the command frame header in G.9903, because in this one and the RFC 66, because in the G.9903, the command frame header is the last one, but by the definition of RFC 66, it is before the dispatch header of the header compression. So inconsistency exists. So I just want to ask the working group's opinion if this draft is authorized to solve this inconsistency, or we just leave this section informational, or we just do not talk about it anymore. So what is your opinion?
Perhaps one point is whether we could receive, for example, on the mailing list, some elaborate information about the nature of the inconsistency, like what's happening in both ITUT and 8066.
I think I can send the two format of the headers. It is just one is the last one. For example, the command header is the last one, and in the RFC 8066, it been said that the dispatch header is the last one. So it is which header is the last one actually. Yeah. So I will send the format of the headers.
Pascal here. My memory is that we agreed on 8266 with the G3 people. They came in the room and we agreed on that format, and that their specification was supposed to adapt to that. I mean, and now you're saying that it's not consistent. So I mean, we should have a kind of a liaison question or something, right? I mean, they were supposed to follow the RFC and to do the thing as we specified. We specified the escape for them. And now you say they don't use it as specified, and that troubles me. I think, I mean, we cannot, you can, at the IETF, you can only be consistent with the other RFCs, right? So you have to be consistent with 8066. I'm just concerned that you're telling us that the ITUT, which came here, so did we define this thing together, now did not comply with it. And that troubles me.
Yeah, I actually, when you see the current version of the G.9903, it is there. It is told that, okay, this command from header is the last one.
But do they, in that sorry, I don't know I've not seen that spec, but can you check if they reference 8066? Because if they did, it's normative, kind of a normative reference. They should obey what the RFC says, because they basically say we're using the RFC, and then they do something which is opposite to the RFC. And what do you build upon, right? You're supposed to build upon the RFC to do the next RFC. And so obviously, I understand you have a conflict, you cannot solve it, but the only thing you can do within this room and this group is to be consistent with the other RFCs.
Okay, I
but
agree.
Now we can talk to ITU and ask, hey, why are you not consistent with the RFC we built together?
Okay, thank you, Pascal.
Yeah, Suresh Krishnan. So just like going a little bit further, like I don't think we can resolve this here. Okay, to be very frank, right? Because if somebody is going to do something else somewhere, there's not much we can do about it. I would say the ITUT needs to fix this if they're doing this in a inconsistent way, like with our standards. It needs to get fixed there, right? Because otherwise, this draft, right, like it's going to get stuck somewhere, because if it's inconsistent with our RFCs, it's not going to progress, right?
Yeah.
So if you want some help, we can probably write up a liaison statement and try to find, I don't know if you have a liaison towards G9903, right? But we'll try to figure out if we can send a message to them saying, hey, your usage of this is inconsistent with how we specified it. That's something we can do and see how things go. But if you have any colleagues who are going to ITUT, who are working on this, like you should talk to them and tell them to fix it over there.
Okay.
I think that would be the right way to do it.
So another question, do you have any suggestion on the text? Should we keep this section or should we just remove it for now?
I would just hold on it to figure out like how ITUT is going to react on this.
Okay.
Okay, and then go from there. So we can sit down with the chairs and probably they can work on some statement to put on the mailing list, and I can send it through the IAB to.
So one point is in the previous version of the document, you had the sentence, which is the inconsistency is being solved in ITUT.
Yeah. So
However,
there's
one
one group in the scope of one group in ITUT. Yeah.
But so does this mean that it's not being considered, like they are not considering solving the
So
inconsistency?
they are aware of this, actually.
They are aware. Okay.
So, okay, then I'm a little bit confused. If they're aware of it and not fixing it, there's not much we can do about it. And we cannot publish this with like obvious contradiction to our published standards.
Yeah.
Right. So let's probably have an offline. Like we have a shorter session today, so we have a little bit time left, and we can have a chat about it offline. On this.
Okay.
The draft does mention that it quotes one of the ITU drafts where it is going to be resolved. So
yeah. So
a future draft which is going to resolve it. So it seems to be on the path to.
Yeah. So my question is actually, should we include this section in this draft?
No,
or
we
not?
wait for it to be resolved. If it's in the process of being resolved, we just wait until it's resolved.
Actually, this feature is just unique to the ITUT PLC. It is nothing related to the other two PLCs. So if we just focus something in common for all the three PLCs, I think we can remove it, right?
Okay, we can talk about it.
Yeah. Okay. Thank you. And we have done some updates about the neighbor discovery section. One of the update is to update the RFC 6775 update into RFC 8505. And we have divided the address registration into two situations. One is the root over mode, and another one is the mesh ender mode. And in the root over mode, for the link local addresses, they should only be registered to the 6LR, which is the router. And for the non-link local addresses, should be registered to the registrar and via the neighbor solicitation and the neighbor advertisement and the DAR, DAC. And if RFC 8505 is supported, the EDAR and the EDC messages are used. And if the address is assigned via DHCPv6 or it is generated via some unique link local link layer addresses, and in this case, the DAD must not be utilized. And for the mesh ender mode, each device is link local neighbor at layer 3 to the 6LBR. So the registration via ICE and AA messages should be fine. So no DAR, DAC, or EDR, EDC message are used in this case. And for the future work, we think that in the structural way, source of the inconsistency we have mentioned yet, we think that in the for the structure, we have covered almost all the technical points for the PLCs. So, but we need help to help us improve it. So, any comments? No.
Okay, so other than the discussion about the inconsistency, is there anyone who would like to review this draft? Thank you very much. It was Laurent.
The next presentation is on V6 over CAN, but it's a remote presentation, but we don't see the presenter in Meet Echo yet. So we'll move on to the next one. 6th law and Lauren.
Okay, thank you. So I will talk about the work that is done at the LP1 working group. So it's about compression and fragmentation. So I will, as I say, I will not talk much about fragmentation, but I will focus more on compression. And we have, of course, things that are common because when we start the group, we have a good source of inspiration that was 6th law. And also on some offer are common to the both groups. So you will find some common things, but in fact, the applicability statement is totally different because we are in very, very constrained network. So here you have some figure about the speed of this network. So some people talk about millibit networks. It's, for example, Sigfox, if you take the duty cycle is 1 bit per second. So it's a very, very limited bandwidth, very, very small frame. And you are limited with the number of frames you can send per day. So you have a lot of restriction. You have also a restriction, for example, then a device can sleep most of the time, so you cannot send downlink message all the time. You have to wait that this device I send messages. So the constraint of traffic is also different than what you have in 6th law network. What is common of all this technology is that we have a star topology. So each device talks to only one point, and we don't have routing around. So it means that this way we can also have some adaptation. So if we look at the architecture, we have a star topology, and we have device that talks with by different means to a central point. And so if we want to do compression and fragmentation, we will do it between the device and this central point. There are also one very important assumption that we took is that we know the traffic sent by the device because it's a limited device and you put your application on it and you can control what are the frames that has been sent or received by this application. So in SHIC, what we do is that we have a context for compression, decompression. So it's on the device and it must be known also in the core compressor, decompressor. So the document right now, IT structure. So we have one draft that explains 3 things. So it's Dominique explained it better than me, but it's divided in 3 parts. The first one describes a generic compression mechanism. So we don't say it for UDP, IP. It's just fields, and we say how we compress a packet made of fields. Then we have a section on fragmentation. So 3 modes of fragmentation that take advantage of the technology and try to limit the number of feedback because, for example, downlink is a very scarce resource. And then from these 2 points, we have a third point that gives an example of compression for UDP and IP. We have other documents, one that explains how to do co-op compression. So co-op compression can be done alone or can be done with UDP IP if needed. So we don't take each layer, but we can do cross-layer compression. And we have also adaptation of the SHIC mechanism to different technology like Sigfox, LoRaWAN, 3GPP, etc. So how it works? In brief, you have a packet that arrives to your compressor. So you have a description of all the possible format of what you are sending. And then if you find something that works, that corresponds, if a rule that corresponds to your packet, then you will send the rule number. And at the other end, since we have the same information, then we can, from the rule number, reconstruct the header. So in the vocabulary of SHIC, this description of headers is called a rule. It's identified by the rule ID. The set of rules is called a context. And for the compression, as in 6 law, we can have the rule ID plus some information that comes from the original header that we send on the radio. So a rule is defined by different elements. So the first thing to identify a rule is that you have a rule ID. This rule ID is absolutely unstructured, so it's just a flat numbering, and it can be used either to identify compression or fragmentation rules. And the size of the rule ID may vary. So if you have frequent rules, they can have a small value, and unfrequent rules that have a longer value. Then the compression rule is structured this way. You have the first field of the first column of these rules are describing the field that you are trying to compress. So you have a field ID that say, for example, it's IPv6 version, or it's UDP port, etc., etc. You have a field position. So it's quite strange if you look at IP UDP, but in CoAP, for example, you can repeat several times the same field as the URI path. So we give the position if it's repeated several times on the header. And then we have the direction, which is something that is very specific to LP1's network, because since it's a star topology, we can have uplink or downlink communications. So with this information, we identified a specific field. And then we have a matching part. So the matching part is with 2 elements. One is the target value. So it's the value that you want to match. And we have a matching operator that tells you how to do the matching with the field. So we have currently four different definitions are done. One is equal. So you must find this target value in your field. Ignore, it means that you don't care about the value. You have also MSB, so you have the first bits must match, and matching list. It means that you have a list of value and you expect to find one of these values. So how SHIC rules works to select a rule is that all the fields that are described in the rule must match with all the fields in your packet. If it's the case, then you can select the rule and apply the compression actions that are described here. And this way it gives you a serialization, what you send on your radio. And on the other side, when you receive something, you receive first a rule ID. So with this, you can identify the rule. And then you have the residue that comes from the compression that can help to reconstruct the original packet using a decompression action, which is symmetric to the compression action in the compression side. So that's in brief how the compression works. So I try to make some comparison between 6 law behavior and SHIC. So first about the context. So context is a very difficult word because everybody has this notion of context. But what we can say is that in 6 law, we have no state for compression decompression. It means that you take a packet, you apply what is given in the bitmap at the beginning, and then you forget this packet and you go to the next one. So every packet is compressed individually. And rules are known by the implementation because you create your bitmap and you say, if I have this bit, I'm doing this, this, and this. In SHIC, it's the same thing about compression. Right now, we take a packet and we do compression, and then we forget about this packet, and we go to the compression on another packet. So here it's similar. The difference is that here, when you receive a rule ID, you don't know what to do if you don't have the rule. So the rule explains you what will be the behavior. So in 6 law, we have a bitmap that can be compared with the rule ID. But in 6 law, it's fixed, and it gives you how you do the compression. As I said before, SHIC, the rule ID is just a pointer to a rule that will tell you how to do the compression. The advantage of having no semantic is that you can have different lengths, and you don't have to structure this information. For compression and decompression action, they are also quite similar in with 6 law. So we have send, elided, mapping, and compute. They are not exactly the same name, but it's they are similar. And in SHIC, we have also MSB, LSB. So it's in UDP, you can do it in 6 law, but it's more generic in SHIC. And it can be extensible. If you want, you can add new compression, decompression action. So in SHIC, in 6 law, it is the RFC that fixes how you apply the compression to IPv6 header. In SHIC is the rule that defines the behavior, and you select one of the actions. So just yes, I would like to ask a question. Who has read one of the SHIC draft? Yeah. Quite a lot of people. So what I think is very variable from SHIC, and maybe we can work together at 6 law with that, is that we define a generic field compression mechanism that can be applied to anything, not only IPv6 or UDP, and to a lot of header. And so maybe it's time now to see how we can work together, for example, to apply co-op compression over 6 law or things like this. So that was a presentation of what we have done. So if you have question or comment, you're welcome.
Remedial from Huawei. So actually, for me, SHIC is just like you have a dictionary at both sides, right?
Yeah.
And you indicate the number of rule, and you can do the compression and decompression. So what do you think in this case, in the meshed 6 law? You mean that we should do some extension in the control plane to indicate the rule, or something like that, or maybe all the context here. So in other words, the dictionary should be pre-installed in all the nodes.
This is one solution. I have no real idea how to implement it, but what is important in SHIC is that you have a point-to-point rule. So it means that if you have a rule number 10 for one association, another rule number 10 can be totally different for another association. Okay. So it means that you don't have unicity of rules number for all your devices. Okay. So if we want to apply in a mesh network, it means that either we try to have unicity in rule ID, or we have to take into account the source and then the rule number. Okay. And the other thing is that since the direction, for example, cannot be used because in mesh, there is no up and down. So you can receive in both directions.
So you mean that there could be some inconsistency of the rule ID in different...
you have to take care of this.
Okay, thank you.
Thank you for this presentation and this work. I think this is an interesting topic. So from some abstract point of view, I agree that SHIC could be viewed as a superset to some of the functionality that is already in 6LoWPAN header compression, for example, the stateless part of 6282. And I think it makes sense to analyze this. For example, in 6LoWPAN header compression, typically in the best case, an IP UDP header, IPv6 UDP compressed header would have a size, in the best case, of 6 to 7 bytes, whereas with SHIC, it could be easily 1 or 2 bytes. For example, there's a trick which is in SHIC. There's this information, that context which is assumed to be static, like forever, let's say. And basically, if you know in advance how your packets or packet headers will look like, you can take advantage of that. So I guess that the design for 6LoWPAN was a bit more generic because maybe the static cannot be, sorry, the context cannot be as static like that, but perhaps there's a subset of 6LoWPAN scenarios that may benefit from SHIC header compression.
One question to the room. Do you see any interest in doing SHIC for mesh networks where we actually need context distribution? Or
I will say it depends of the constraint of the SHIC networks. You have a trade-off between the effort to send the rule everywhere and the benefits of doing that. So
do we have such do we have a study where such networks are documented where it makes sense to actually go apply SHIC in 6LoW?
I don't know, maybe in the YSON, maybe it could be interesting to see because they have both topology.
Could we enhance this draft with that data where it makes sense to bring in SHIC in 6LoW?
Okay.
Thank you.
Yeah, Carsten Moorman, this probably has been said in one way or another, but I would just like to keep in mind that both 6LoW and SHIC have context. They differ in how extensive this context is. So in 6LoW, we can essentially only provide a few addresses that then can be used by the 628.2 compression mechanism to compress some addresses a little bit, while SHIC, of course, has this extensive mechanism. In SHIC, so far, the assumption has been you provision this per pair. In 6LoW, the assumption has been you provision this per network, or we talk about area context. So whole 6LoWPAN shares the context. And of course, you can open this up again and shake it in quite different ways. So if we did 6LoW with per pair context, that would feel a little bit different. Or if we did SHIC by distributing the information to everybody, that would feel different, and so on. So I think there are a number of combinations one could look into here, and it would indeed be interesting to see are there the use cases where these combinations actually make sense, and if yes, what is the level of efficiency that actually can be achieved. But I think the main difference is again, how do you distribute the state, who gets what state, and how extensive is the set of compression actions you actually can express. And of course, in the latter part, SHIC really is way further than 6LoW.
Agree.
Pascal, Hubert, there's also this concept of backward compatibility, etc. So what I just looked at is how much space we have in the NHC field of the 6LoWPAN compression, because one way of using SHIC, and you mentioned YSON, one way of using SHIC is to actually leave the header compression to 6LoWPAN because it's doing it, and the intermediate nodes know what to do about it, and we know how to fragment and forward the fragments over multi-hop, etc. So you could think about leaving IP compression to 6LoW just for backward compatibility within your mesh, but upgrade some endpoints to have a new NHC next header compression for SHIC. So instead of saying the next header is UDP, right, which we do today, or you have those we don't really compress, there is a list, then we could say, oh, there is this other sort of next header, which is SHIC. And the cool thing now is you could transport SHIC for the upper layers and still use 6LoW to forward the packet inside the mesh. And
here you come back to point-to-point association.
Well, yes, which is what we want, right? Because every point-to-point may have a different compression and depend on how far you want to compress things, etc. So it looks like an idea to be able to transport upper layer compressed with SHIC, whereas the mesh itself is still 6LoW. And I know CoAP, well, you mentioned YSON, but for all I know, the CSMP protocol, which is the CoAP simple management protocol, is CoAP. And so I already see where and how SHIC could be useful for managing the devices with a lower cost by using SHIC to compress the CSMP messages, for instance. So I see it very valuable. So that means for 6LoW, that's where it becomes quote unquote interesting for us we end up with a document explaining how we make it so that the next header is SHIC, which we don't have today. So once you see that, you can decide when you decompress, and that can be at the edge of the network or at the endpoints.
I think we have run out of time. We have 2 more presentations to go. Thank you, Alan.
I'm sorry, another advantage is effectively when I mean the endpoint, I really do mean the endpoints. Like the problem with if you use SHIC for IP is that the first router which goes to the internet has to speak SHIC because it needs to decompress, and it might decompress the whole thing. But now if you say, oh, I'm using 6LoWPAN for IP, it means that I can reconfigure, I can rebuild an IPv6 packet where the content is hidden within UDP to pass through the firewalls maybe, but it's SHIC. And so if you do that, then the decompressor is really the application, which is kind of cool because you don't have to put state in the network, it's at the endpoint.
Thank you, Pascal. Alexander, we see you online. Could you join the queue so that we can make you the presenter? We are going back to the CAN presentation, and then we can do the asymmetric. There used to be a red button. Okay. Can you say something? No, we can't hear you. He has to join the queue, right?
He's there. So
Yeah, but he has to join the queue so that we can make him the presenter and he can speak. There is a presentation mode. I think if you. Yeah.
Hello?
hello.
Can you hear me?
Yeah.
Yes, perhaps a bit louder, please, if possible.
Yeah, I can try to talk a little bit louder. Or... Yeah, where can I switch the slides?
Oh, you can ask us and we'll pass the slides for you.
Oh, okay. Yeah, so hello, I'm Alexander. I'm the author of the 6LoW draft. And can you switch the slide? Yeah, why do we actually want to have IP version 6 over the CAN bus? Because IP version 6 is technology and vendor independent. We have lots of application layer protocols like CoAP and MQTT and whatever IoT protocols we have today. We can have transport layer security because the CAN bus is actually not encrypted. And we gain routing with that, and we can have even access to the internet with the small devices. Can you switch the slide, please? But why do we want CAN bus for the IP version 6? The CAN bus is actually, it has a broad availability on small scale MCUs, for example, 8-bit MCUs, and also large scale, like the ARM application processors. It is very cheap, actually. It has a very small hardware footprint. There are just small components in addition you need to the controller. It's a very robust bus. It has a simple wiring, and it's actually widely used, even though we don't see it today. Can you go to the next slide? One before? There was one in between. Yeah, the CAN bus is a multi-master bus, so we have multiple slaves connected in parallel together. It has a line topology. It is a 2-wire bus, and we can have up to 1 megabaud speed. And for the new version with the flexible data rate, we can have up to 8 megabaud. but that heavily depends on the path length. The next slide, please. This is what a CAN frame looks like. We have either 11-bit or 29-bit identifiers, but those identifiers, they are not node addresses, but they identify frames. We have up to 8 bytes of payload in classical CAN and 64 bytes payload for the flexible data rates frames. But for IP version 6, we need node addresses. It was okay. Please, next slide. For IP version 6, we need node addresses. So the draft creates a node address, which is 40 bits wide. It can either be randomly assigned or statically assigned to the nodes, but it must be unique on the bus. Next slide, please. But how do we map those nodes identifiers to the identifiers of the CAN bus? We just stitch them together. So in the higher 14 bits, we have the destination address. In the lower 40 bits, we have the source address. And the most highest bit is a multicast bit. The next slide, please. For multicast, we just set the multicast flag to 1, and then the destination address changes to the multicast group. Next slide, please. Yeah. To guarantee the uniqueness of the node address, we introduced the link layer duplicate address detection, which takes a special kind of CAN frame. The CAN frame has an RTR bit, which means remote transmission request. And such a remote transmission request is sent out with the tentative address we want as a destination address and some entropy in the source. And then we wait at least for 100 milliseconds for a response on the special address we can see here. The special address is the DID address. And if the source address is the tentative address and we get a message, we know that this address is already used. And if you don't get a message, we can guarantee that it's unique on the bus. Next slide, please. Because we only have 8 bytes of payload or 64, we need some fragmentation and reassembly because the minimal MTU, as we all know, is 1280 bytes. But the 6-low fragmentation is too bulky. The 6-low fragmentation would already need about the half of the payload for every frame. So I used another fragmentation and reassembly protocol, which is specified in an ISO standard. It's the ISO-TP protocol. It provides us fragmentation and reassembly, and it also has flow control, but only for unicasts. Next slide, please. We also use the 6-low IP header compression. Because of the big IP header for 40 bytes, this would take 6 CAN frames. And with the compression, if you're lucky, we can go down to 3 frames. Next slide, please. We also introduced a border translator. This border translator translates the traffic on the CAN bus to the Ethernet. So it does the reassembling of the frames, and then it extends the addresses from node addresses to MAC addresses and forwards them to the Ethernet. So the translation is on the link layer, and devices behind the Ethernet they are also in the link local domain. Next slide, please. We have also reference implementation. The 6-low CAN is already implemented in the Zephyr RTOS, and it's there since version 2 in the mainline tree. There are examples to test. Yeah, that's okay. So are there any questions?
I think we can have the discussion on the mailing list. We have one more presentation to go, and we have about 10 minutes. Thank you.
Hello, Guangpeng Li from Huawei. Today, I will talk about the asymmetric IPv6. This is the second time we present this draft. Here, give a simple reminder. There are there are many steps in asymmetric IPv6. The first one is define address length n within a domain, and second, we will use all addresses inside the domain have the common prefix with the length of some bits. The bit length equals 128 minus n. And then we will route on the shortened addresses. And more, or we can eliminate the unnecessary header fields. And the third method is reuse the version fields and replace it by 12 encoding bits. Okay, this is a simple example. The first 12 bits are encoding bits, including the flexible header encoding octet and the modified version fields. And then the normal IPv6 fields, but part of them can be elided when needed. So more details is in the draft. So you can read the draft and maybe have some comments or questions. Okay, last time we got some comments for the relationship to SHIC. Here, after that, we read the SHIC drafts, and we think SHIC is a good mechanism to reduce the packet size. And of course, it can express asymmetric IPv6 compression also. But we think SHIC is static. That means after context is established, the fields to be compressed do not change. And but asymmetric IPv6 offers dynamic choice of the fields to be compressed, because the coding bits are included in every package. So in asymmetric solutions, the short and the long addresses can be used in the same package. Okay, any comments or questions?
Just in 6LoW is the same thing. You cannot have a context and store information between two packets.
We use the bitmap and the dispatch together. So it's a combination of them. I read your draft about your draft. So it may be equivalent to a rule ID, but we think we should specify the concrete rules for the simplest device implementation. SHIC is a common use oriented.
Okay, any other comments or questions? So one question would be that in the new version of the document, there's the section which compares your solution with SHIC. However, I hope I haven't missed it. I didn't find a comparison with existing 6LoWPAN or 6LoW header compression. So how would your solution compare with the existing one in 6LoWPAN?
Yes, the difference between our solution and the 6LoWPAN is that we route the packet with the short address directly, not decompress hop by hop. Because the short address is a real address, not a compressed of IPv6.
Well, any other comments, questions?
So I have a question for Charles. Do 6th law need draft of how to define the how to defend the comparison of IPv6 drafts?
In context of 6th law or any network?
6th law? Yeah.
That's in the charter.
Yeah, yes. So I think asymmetric IPv6 is an alternative solution than already existed. It's a new one. I mean.
Can we ask you to add a section on advantages of this over the existing 6th law, similar to what you have done the comparison on SHIC? Could you add the advantages of this, or where this makes sense over the existing 6th law header compression? And then we'll get it reviewed from the work group and see how to progress.
Okay, thank you.
Okay, any other comment? Yeah, so regarding the IPv6 over CAN, there has been activity and questions and comments on the mailing list. However, is there anyone who would like to volunteer to review that document? Well,
I just wonder for the IPv6 over SHIC, and I thought Laurent would come. Oh, I'm sorry, over CAN, 6th law CAN thing. I was just curious if SHIC was considered, because it makes so much sense to use SHIC there. So I mean, before we go deep into the bits of 6th law goes this way or this way, there is one problem which needs to be addressed anyway, is address assignments that's orthogonal to the compression. So that can be discussed already. But I'd like to make sure we agreed that we want to have a 6th law solution or we want to have a SHIC solution.
Yeah, I did not consider SHIC because I was not aware of it so far. So, but I can have a look at it.
Yeah, it looks very interesting considering the constraints you have. I mean, it looks really, really interesting to consider SHIC.
Yeah, thank you.
Yes, one point is that for fragmentation in IPv6 over CAN, maybe in addition to considering ISO-TP, perhaps you might consider the SHIC fragmentation as well, which is really targeted to very constrained payloads like the one you're dealing with.
Yeah, the good thing about the ISO-TP is that it only uses 1 byte for the fragment headers, and it's actually made for CAN, and it's a well-known protocol, and there are implementations, and it also has this flow control, and this flow control can consider some kind of wear leveling, or not wear leveling, it's considering block size and separation times where you can better steer the demands of your receiver so that you're not overflowing the receiver. And yeah.
Well, one point is ISO-TP the native fragmentation mechanism in CAN devices or technology?
Good question. There is no native fragmentation because CAN is only the physical and data link layer, but it's already there for a long time, and so I try to use it because it works actually, and it's.
Yes, I think that considering, well, from the IETF we have from the LP1 working group the SHIC fragmentation, which you might want to look at to see whether it might also fulfill your requirements here. It's also able to perform fragmentation with flow control and fragment recovery. There are different flavors there, and also it's been designed for technologies where the MTU is really low, really small. So perhaps it's something in the lines of what you want here. So maybe considering that would be of interest. Okay, any other comment? Okay, thank you everyone. The session is closed. So see you all in Vancouver.